Okay. So I watched like a minute of this Leetcode video, and I kind of got an idea on how to proceed. Let me show you. I kind of drew like a drawing. I was kind of just brainstorming, and the mistake I was making before was, you saw that I kind of slashed out like the 2 and put in a 7, and slashed out the 7 and put in a 2, right? But really, like, we're actually just switching the entire, like, this left subtree, we're switching with the right subtree. Like, the arrows are already there, but let me try a different blue color. We're switching the left subtree with this right subtree, and then the right subtree. We're switching the left and right subtrees basically, and so this subtree becomes something like this: 2 and 1 and 3, and then down here you gotta repeat kind of the same process. Imagine there's like more children down here, like, you know, there can be many children, but the same thing, you're changing the subtrees, and then it kind of matches that property of 3 and 1, and 3 and 1 would be the scenario there too. So very much a recursive process, where like you kind of start off with 4 and be like, okay, as 4, what do I need from both of my children, right? I'm ordering my children to do something, you know, I'm delegating that task to them, and then they're going to come back with that task if completed. It's kind of funny making children do work. I don't think that's whatever, it's fine. Okay, making your children do work, right? And then your children do the revert, how do you say this, reversion? Like, they revert the trees swap, like the subtrees swap. Maybe that's a good way to put it. And so at the end of the day, this 4 doesn't care about all like this 2's children swapping and then the 1's children swapping, and just wants its children to swap. And then we tell 2, you know, 2 is like, okay, now my children, you need to swap. 1's like, okay, children, now you need to swap if it hypothetically adds more children, you know, and the process goes on and on. I don't know if I explained that well, but let's see if I can translate that. If I can translate that to code. I was kind of writing it out already over here. I had something written out. If there is no root, the root is nil, then we return nil. I'm a bit concerned if there's just a root node, if this is gonna work like this line, like, because this is gonna be technically nil is equal to nil. So I'm just a little bit concerned that this may not work. But let's see. I'm hoping it just, like, this just passes through, like nil is equal to temp. I don't know, something feels fishy about this. And then this both of these calls would just end up like returning nil, and then you just return the root. And I got a typo there, invert tree. Yeah, we're not really using the inverted value. So I think we do want to do something like root dot left is equal to this, and root dot right is equal to that. Or maybe actually right is equal to this, and wait, hold on, what am I doing? Something's not right here. Okay, hold on. So first of all, just root scenario. That'll be something we need to consider. But let me just walk through this example here just to make sure that this is actually working. I don't think it is. So we have a temporary variable we save root.right, and yes, there is, there's this entire subtree on the right that's being saved. So that's there, and then root.right should actually be equal to root.left. So now that's over there. Okay, cool. Then root.left should be equal to the temporary, which is root.right. So it does the switch. Now we gotta invert the tree on root.left and root.right. But how do I bring that back to my own scenario? I think I need it like this, right? Because then the left, right? We've already done the inversion over here, but now inside this inversion, it's gonna go into its right and left children and do the inversion there, and then return it back to root.left. Yeah, return root. I think this is the way we want to do it, because then root.left. So let's go into invert tree, root.left. So now it's going to be 769. Okay, then we do the same thing. Var temp root.right. So save a temporary variable for 9. Root.right is equal to root.left. So this is now equal to 6, and then root.left 6 is equal to temp, which is 9. So now it's going to be 9 and 6. And then we try and do this, but we realize that none of these actually have children, so both of these will return nil. Whoa, hold on. Wait, I don't want 7 to have no children though. That's not right. Right, because this is 7.left and 7.right. So I don't want that. But I want if it returns nil, then what do I want? Well, it's not going to return nil actually, sorry. Root.left is, like I just said, it's going to be 9. So when we come here at 9, it's not going to return nil. It's going to come here and try doing root.right, which is nil. And nil is equal to nil, and nil is that. And then it tries inverting the root.left of 9, which is nothing, and then that returns nil. And the same thing with root.right. Now this is like, it's my point of concern. If this is actually going to work. Let's see. I've thought about this. I've been doing this for 9 minutes now. Let's see. Okay. Optional tree null cannot be used as a boolean. Okay. Okay, fine. So we'll do something like if let root is equal to root guard let root else return nil. Cool. Okay. If I do this, do I need the optional here? I feel like I don't anymore. Yeah, you can't do optional chaining on that. But now this is gonna give a problem. I know for sure this is gonna give a problem. So I'm just gonna do if let right is equal to root.right. Root.right is equal to root.left. if let left, maybe I'll just do if root is not equal to nil, and if left is not equal to nil, or yeah, left is not equal to nil. Okay, and then we don't even need these optionals anymore. Don't need these either. Let's see. Nice. Okay, now let's try removing this. Is this gonna give me a problem? I think it is. Like, it just makes sense that it's gonna give me a problem. Like, setting null equal to that is... maybe it won't. Let's see. Interesting. Interesting. That is so interesting. If I submit this, does this work? Interesting. How does that work? Can I, I'm gonna pull up a Swift compiler and just try that. Like, nil is equal to 3. Hold on, what's the check here? Yeah, nil is equal to 3. Nil is equal to nil. Okay, this gives an error. Wait, did the one before give an error? Yeah. Var hello. This doesn't give an error. Okay, I feel like it's just not covered in the test cases. I feel like this would give an error in most scenarios. So I'm just gonna wrap this up again. And I'm gonna try running that, like submitting that again. Oh. Okay. How does that make sense? So we have a temporary variable root.write. Okay. If root.write is not equal to nil, then we do root.write is equal to root.left. So 1, 2. Well, root.write is equal to nil, so skip this. So it's not going to set the write to anything. But root.write is also, so it's equal to nil, but it's also like a reference, right? Like it's a property in this variable, so it doesn't matter if it's nil or not. But you're setting it like it's a tree node, which can be an optional or a tree node. Oh, okay. Sorry, I guess I overcomplicated that. Doesn't matter if this is nil because write is a property in this tree node, which can be either a nil or a tree node type. So either way, that's good. And submit. Cool. All right. Okay. Done with that.